Alright, so by request, somebody wanted me to look at some of this section 4.1 homework, so I'll just write out a few of them. Maybe this will help you. So we're supposed to subtract the polynomials. So we've got 12c. I guess you probably couldn't see my phone, so I'll just look at it. 8h minus 7p minus parentheses 4c plus 13p minus 11h, if I've copied that down right for mine. So we're supposed to subtract them, right? And so I'm going to go ahead and do my work down here, if you guys don't mind. This is one of the later problems in this section, by the way, because I took the pictures in the opposite order, you know, so my first picture is further down my camera roll. Anyway, I'm just going to go ahead and do this step. So not doing anything, just rewriting the first thing again. And then minus, I have to distribute that minus through. So I got minus 4c minus 13p. Minus a minus gives me a plus 11h. Alright, then collect like terms. Alright, so if you're getting this wrong, I bet it's because you didn't distribute the minus in, you know? So these guys go together. That gives me 8c. And then this 8h goes with this 11h, and I get 19h from that, yeah. And then, what else? Did I get all my h's? Oh, I didn't get all my h's. Oh, man. There's 3 h's. Oh, phooey. I still got to subtract that 7h. I'm going to have to write another step. Rats. And then, of course, you just got the one. Oh, man. 12c plus 8h. So maybe I shouldn't even be trying to do this right now, guys. So that was not 7h. That was 7p. I just wrote it down wrong. So sorry about that. I'm not operating with a full deck of cards here, so to speak. But I'm going to try. I'm going to try here to give you some pointers. If you can see past my, you know, let's see here. I got 8h minus plus 11h. Right, but I've also got that h. That's it, though. There's no other one, right? So I just got the plus 19h. And where's the p? I got this p and that p. So it's minus 20p. All right. So this is not hard. It's just that I am sick. So anyway, this is like section 4.1, number, what did it say? Number 69. It's based on that one in the book. All right. Let me go back here. Supposed to see if you can see it or not, I don't know, but we're supposed to subtract the polynomials again, right? Alright, so scooch this up a bit, just right on here. So, and this is, well, I can't see which problem this is based on. It doesn't really matter which one this is based on. The point is the math. So, okay, 2w minus 9 minus 5w plus 9. Alright, so first order of business is to distribute the minus, because that is our principal vice, is not paying attention to that minus. Minus gives me plus, minus gives me minus. Alright, what do I got? 2w, 5w gives me 7w. Minus 9 is minus 18. So, there you go. That's how that goes. Let's look at another one. I'm working my way back to the start of the section. I picked the problem of pretty much every type. So this one is 4.1, number 51. Again, I don't know if you can see I'm not sure my screen actually, you can read or not. Just trying not to cough at the moment. Okay, so this is section 4.1. It's based on section 4.1, number 51. And, okay, so this time we've got 5s squared plus 8s minus 13 SG minus 9, all right, plus, oh, that's nice, minus 14s squared minus 6s plus 8SG plus 7. All right, so I'm supposed to add these guys. So I'm going to do it down here. So basically, you can just erase the parentheses and collect like terms. We've got 5s squared minus 14, that's minus 9, s squared. 8 minus 6 is 2s, so collect like terms. Minus 13 plus 8 is minus 5, sg. Minus 9 plus 7 is minus 2. So what I've done is I just collected like terms and did the addition by adding their coefficients, all right? So that's how you add. You add like terms and add or subtract their coefficients as appropriate. All right, so let's see here. Next problem was based on section 4.1, number 47. 5s minus 2n plus 8g, all right, plus 5s minus 6g plus 10n. All right. So again, with a plus, I don't have to worry about distributing the minus. I can just, get at it. So 5 plus 5 is 10s. Minus 2 minus 6 is minus... Oh, wait a minute. Hold on a second there. I almost fell into the trap. Look at that. These sneaky, sneaky people. They switched the order of this. See, that one goes with this one. And this one goes with that one. They tried to trick us. We won't be tricked. Minus 2 plus 10 is plus 8n. Minus 8, 8 minus 6 is plus 2g. I apologize for my wheezing. It's not really wheezing. Actually, my blood ox is better than it was. I just got some kind of, I don't even know. I'm just tired of it. All right, my wife has theories. I won't share them with you because we'll see. We have to see how her theories bear out. Maybe tomorrow I'll figure it out. All right, anyway. So so this one is, I mean, maybe I'll show it. Maybe you can see it. Maybe you can't. I don't know. Oop. Probably not. But I'll write it down again. This is section 4.1, number 45. All right, and here we're supposed to add 3b squared plus 10g squared plus 3. Now, probably the person who asked me to do all these problems is like, these are not the ones I had trouble with. I was talking about the weird problem at the start of the problem set. And I get it. I'll get to that one eventually. We're working backwards to the front, basically here, okay? The first problem's got a lot of words in it, and don't be scared. I'll try to unwrap it. Hopefully we can see the words on my screen. I really don't want to write all those. I'm just going to read them when we get to it. Okay, so it's again a plus, so I just need to, matching terms. So 3 plus 5 is 8b squared. We got here 10g squared minus 8g squared is plus 2g squared. And, oh, may not cap that, I'll leave it open. And, where are we? Oh yeah, what's left? The constants, right? So 3 minus a 2 is 1. So, there you go. Added. All right. Great. Next up, collect like terms. This is question 7 in the My Math Lab. I'm not sure which one it's based on in the book. Although, I don't know why I'm worrying about the book, because as we already agreed, you guys don't read the book. Let's see here. And I think that, honestly, is one of the great problems with using electronic homework, is you guys ignore the book. And, well, I don't know. maybe there's something to learn there, you know. At least it'd be a place to see the math talked about a slightly different way than I talk about it. But anyway, carry on if you figure out what works. You should notice by now that, like, we're going to have a quiz, right? We're going to have a quiz before the test. And so when that quiz happens, you need to pay close attention to what you get wrong there. Because if you can figure out what you got wrong and how to fix it, you got a real chance at, like, knocking test 2 out of the park, right? So my quizzes are essentially a practice test, okay? Although I think the quiz will likely be shorter than the test because I don't think I'm going to have... I just don't want to grade that long a quiz. And anyway, and also you'll have a little bit less time pressure on the quiz, so there's that. Actually, probably what we'll do is the quiz will take, 40 minutes of class or something, and then we'll use the other, 35 minutes of class to go over the solution of the quiz. That might be what we do. I need to look at the course planner to be sure. But anyway, collect like terms. Alright, so I'll use some color coding. As you know, I like the color coding. So 10B, where's my other B's? Here's another B, and I do mean the letter B. Let's see here, 10 plus 7, 17, 17 minus 11, also known as 6. 6 B's. Alright. 9, so let's do the constants. 9 minus 7 is 2. 2 plus 6 is 8. So just some color coding here, so I'm adding and subtracting, and then adding again and again. So like I'll do it a different way. 6 plus 9 is 15, 15 minus 7 is 8. So we got 8 two different ways, so either I'm wrong twice, which would be very unfortunate, or I'm right. Alright, collect like terms again. I should have put my math lab into night mode or something. Maybe that would have taken a better picture. I don't know. Anyway, excuse me. Collect like terms. Alright. Collect like terms. Lovely. So we've got 7W minus 4D minus 3W plus 28D. Alright. So get another color here. You got this one and that one. That's all your W's. 7 minus 3, 4W. You got minus 4 and 28. 28 minus 4 is 24. And that's it. That's all there is. There's either W's or there's D's. Solved. Alright, so, these aren't really that bad. Collect like terms. Collect like terms. And the instructions are the same. I'm just going to write the problem down here. So the problem is 9c squared minus 17c squared plus 20c squared. I'm trying very hard not to cough right now, if you're wondering. So like 29, 20 plus 9 is 29. 29 minus 17. Oh, It's 19. 19 minus 7 is 12, I think. Let me try it a different way. So I do 9 minus 17. That should be minus 8. Minus 8 plus 20 is 12. Okay, I got 12c squared two different ways. That's probably right. If in doubt, use your handy dandy calculator. Now here's something that we haven't talked too much about, but this is actually an important skill. So here we're supposed to, we're given a polynomial formula, polynomial function, and we're supposed to evaluate the function at the given values of the variable. So all that means, right, all that means is to plug in the value into the formula. So this is 4.1.19 basically. And so we're given the formula for the polynomial p of x equals to 5x squared. And I don't know, your problem might be different. Some of these might be randomized. I'm not sure how lazy my math lab has been in their coding of these problems. If you're lucky, it'll be literally the same problem. And if it is, my apologies for doing your homework for you. The important point really is not that some people do the homework and get points and other people don't. The important thing is that everybody takes enough time to do the homework and that they understand it. That's the point. All right. So, I mean, we really expect everybody to pretty much get all the points from homework by the end of the semester. That's why I keep reopening, the sections after they're due. I don't do that with tests, by the way. All right, so P of 3. That means I take x and I put x equal to 3. So that's P times 3 squared, because that's where x is, right? Minus 2 times 3. Wherever there's an x, I put the number. And then plus 8. All right, so then I have to work that out. 3 squared is 9, so I've got 5 times 9. And then, of course, that's 6, right? Plus 8. So I've got one more step. That's 45 plus 2. So we got 47. 47 is the value of the function when we plug in x equals to 3. So one of the things this means, and I'll just, comment. I mean, while we're at it, let's say something interesting. This calculation means that 3, 47 is on the graph of this polynomial. So like that's a point. If you're to write, y equals to p of x, well that's a quadratic, that's a parabola, and the point 3, 47 is on there. All right, now we know all kinds of other stuff about parabolas because we looked at chapter 7, but just saying. Okay, p of minus 1 is the other thing they ask us to do. So we gotta take 5, plug in x equal to minus 1. So we put x equals to 3 for this one. We put x equals to minus 1 for this one, all right? So minus 1 squared minus 2 times minus 1 plus 8. All right, homework down this time. So that's 5. Minus 1 squared is 1. Minus a minus is a plus, so plus 2 plus 8. So 10 plus 5, 15 is the answer here. And we're also asked to calculate p of 0. Now that's actually a lot easier because we learned in our study in chapter 7 that p of 0 is just the constant term, right? That also gives you the y-intercept of 0, 8. But I'll just, just to stick with the theme here, I'll plug x equal to 0 into the formula. And that goes to 0. That's 0, and we just left with 8. All right? All right, next question is 4.1.13. All right, and we're supposed to arrange terms of the polynomial. Arrange terms of polynomial in ascending powers. Ascending powers of c. All right. So they give us to start with, I'll go back to red, 9c. Let me see if you can see what I'm writing. Yeah, you can. 9c plus 7 plus 5 c to the 7th power. Ooh, that's a big one. Minus 4 c to the 5th power. So in ascending, right? So we sorry. I made it so far. All right, so the ascending means I put the constant, that's the lowest degree first, 7. What's up next? The linear term, 9c. What's the next one? Minus 4c to the 5th, right? And ascending, so the last one plus 5c to the 7th. So this is actually like kind of the opposite of what I was mostly doing in class, right? Which was I was saying like the standard form writes the leading term first. In this format, the leading coefficient is the coefficient of the last term. In this case, 5 is the leading coefficient, right? And just saying, it's the leading coefficient of this 7th degree, I can't spell, polynomial. Ooh, this marker is near dead. Hopefully make it. Hopefully make it. Oh my goodness, I had not zoomed in yet here. Oh, this particular problem is like so wide on the screen, it's hard for me to take a picture of. It's like identify the terms, the degree of each term, and the degree of the polynomial. Then identifying the leading term, the leading coefficient, and the constant term. List the terms of the polynomial and use a comma to separate answers as needed. What on earth? This is horrible. Like, how? When I assigned this, this looked like a reasonable problem, but I'm not sure, like, the format here. Identify the terms, the degree of each term, and the degree of the polynomial. Then identify the leading term, leading coefficient, and the constant term. And then list the terms in the polynomial. Okay, what are you supposed to list? Are you supposed to list the leading coefficient and the constant term? Or are you just supposed to list the terms? Clear as mud to me here, folks. If you want to skip this one, I would not be bothered. But here's a potential interpretation to this. So here's the formula that I'm reading. Maybe you can see it. Minus 3r to the 10th minus 11r to the 4th plus 4r cubed plus 4r minus 5. Why isn't that showing up? Where am I? Oh, there it is. Sorry, guys. Plus 4r cubed plus 4r minus 5. All right. So what's the this is the leading term. Leading term. This is the constant term. And if I had to list the terms, since they didn't tell me to list just some of them, I would say minus 3r to the 10th, comma minus 11r to the 4th, comma 4r cubed, comma 4r, comma minus 5. That seems dumb. So I bet what they meant here was list the terms that we said were interesting in the previous part of the problem, but we can't be bothered to write here. All right, so if I had to guess then, they might be looking for the answer. Here's my best guess, guys. The leading term is that, right? The leading coefficient, minus 3. The constant term, minus 5. This seems to me to be a potential answer. To me, this would be a logical answer. So, you know, all right, I've talked enough about this problem. Let it be dead to us. All right. All right, so I think this is the, yeah, here's the first one. Let's see if I can zoom in enough. So here we have 4xy cubed plus 3x cubed y plus 5xy cubed minus 7x plus 11 minus 3x squared y minus 2x squared y plus 12x minus 8. What are the like terms? Well, xy cubed. Do we have any other xy cubed? Right there. 4 plus 5. Any other xy cubed? Nope. So 4 plus 5. So we got 9xy cubed. So, oh, okay. So it's asking what are the like terms? Like terms are two terms that have the same coefficient. No, that's not it. Like terms are two terms that have the same sign. Irrelevant. Like terms are two terms that have the same variables raised to the same powers. We have a winner. That's what we mean by like terms. All right. So like terms are two terms that have the same variables. Here we're missing the concept of power matching. So D is not the right answer. C is the right answer. So anyway, guys, I hope that helps. Enjoy. Thanks.